Hello, this is Joe Neville, and in this video I'm going to be showing you how to build Cumulus VX devices with Vagrant. VX is the virtual appliance from Cumulus. It's free to download and it's a great way to get hands-on experience with a version of Cumulus Linux. As a VM, it's supported on a number of hypervisors, but I'm interested in using Vagrant to build it, which has advantages such as allowing me to boot multiple VX devices at once, plus offloading some of the manual provisioning steps. First of all, you'll need to download a number of files. I'm running this demo on a Windows 7 box, so I go to the Vagrant download page and download the relevant version of Vagrant. We'll also need a hypervisor. Now, Vagrant is free, but they charge for integration with VMware. So I'm going with the free version, which is using VirtualBox. So we download VirtualBox from here. And rather than use the Windows command line to control Vagrant, I prefer to use git bash, which allows me to easily SSH onto my Vagrant boxes. So we download that from here. We need to download the Cumulus VX image. So as you can see, you've got VX for VMware, VirtualBox, KVM. We're going to go with the Vagrant box, which we download here. Once all those files have downloaded, install VirtualBox and Git for Windows. And to install Vagrant, you'll need to reboot your machine to complete the process. So once all that's done, open up Git Bash. And we need to add a Cumulus plugin to Vagrant with the command Vagrant plugin install Vagrant-Cumulus. So that plugin has installed successfully, and now we need to create the Vagrant box for the Cumulus VX. And we do that with this command. That's Vagrant box add Cumulus-VX-2.5.3, so that's the name of the box, and then the path to the .box file that we've just downloaded. So that's successfully added the box, and if you now go to your user directory, you should find a .vagrant.d folder, and in here you have a Vagrant file. So this is the default Vagrant file. Now for this demo, I'm going to be building a simple 2VX device network, CVX1 and CVX2 connected via a /30 network. Each has another interface with a prefix that they're going to import into BGP. Then we're going to build a BGP session between the VX devices, and we're going to propagate these prefixes. There are some potted demos available from Cumulus, but I wanted to break open the process a little to learn a bit more about how Cumulus and Vagrant work together. So here's the default Vagrant file that's been created, and I now create a new directory which I've called VX Sandpit, and I copy the Vagrant file across to there. So VX Sandpit, we create a new Vagrant file, and it's that one that we're going to build the configuration for the demo. So if we open that up, you can see the configuration here. So to break that down, we've got two VX devices, CVX1 and CVX2. So they're defined in this line, and we tell Vagrant that these are the Cumulus-VX box. Now this is useful because we can pre-provision the interfaces for the VX device using these commands. The order is relevant because this will be the first switch interface and this will be the second. So as you can see, cvx.vm.network, we've got the 192.168.50.1/30, and then we've got the other end of that /30 configured on CVX2 down here. And the second interface is the local address that we're going to import into BGP and advertise. And then I've taken that a step further by incorporating some shell scripting for our provisioning. Now, if you were to provision a Cumulus VX device using the default settings, these IP addresses wouldn't be configured, so you would have to manually configure, but also the Linux daemons that are needed to start up the Quagga routing process, so that's essentially the routing processes on the VX device, they would need to be manually started as well. So there's quite a lot of manual interaction that you need to make once the VX device is booted prior to being able to get onto the command line and actually start configuring your routing processes. So we've cut corners here by provisioning those two IP addresses, but I've also referenced here a shell script. So with this CVX VM provision shell, and that's the path to the shell script. So I'll show you what that's doing. Here's my shell script for CVX1, and I'll just step you through it. First of all, we turn off the Quagga service. Then we replace the no parameter for the Zebra daemon and the BGP daemon with yes. So what you would have to do normally is manually go in and change these settings, but here we're doing it beforehand. And we're also adding the host name of the device. So CVX1 is being configured here, etc. host name. And then we reboot the Cumulus VX. And this all happens prior to us actually logging into the device. So we're actually pre-provisioning our devices so that we can just log straight into the device and we can move forward with the configuration. I should mention that because there's device specific information in here, namely the host name, I've built two shell scripts, one for each device, which you can see here. And just going back to that Vagrant file, then you can see that they're referenced. CVX2 is referenced here. From our git bash, if we go into our directory, we can just bring up these two Cumulus VX devices with all that provisioning done, the host name set, IP addresses, and the daemons running with a Vagrant up. So you can see CVX1 is now booting. And now you can see the process is being stopped. So that's the shell script being activated. And then we move on to CVX2. So now both have booted. Now we log into the devices using Vagrant SSH and the name of the box, so CVX1. Once we've logged in, you can see that the host name is set, CVX1, and if we check the Quagga daemons, you can see that Zebra and BGPD are set to yes. Now, if we hadn't done that pre-provisioning, these would all be set to no, and we would have to manually set them. So our daemons are running. That's great. Now we can log into the Quagga process with sudo vtysh, and there we are. You also see that the command line here, the host name of the VX is set, so that's copied from the Linux host name. And anyone that's familiar with Cisco IOS will feel right at home here. Configuring BGP, it's very easy. It creates our neighbor, and we'll create local network to be imported. Exit out of there. And Vagrant SSH to CVX2. Sudo v2y sh. Conft. Oh, let's go back in there. If we do show IP BGP summary, we can see that the neighbour's already up to .1 and we're receiving a prefix there. So if we check the BGP table, you can see the local prefix being learned on CVX2 and the remote coming from CVX1. And once we're finished and we've logged out, we can blow the demo away with Vagrant destroy-f. And it's as simple as that. Hopefully that's provided you some insight into how to build a sandpit environment for Cumulus VX using Vagrant and how to cut some corners in the manual provisioning. I've written all this up at my blog nullzero.co.uk. But for now, thanks for watching and goodbye.